All right, guys, Mr. Jenkins back here with some new instruction. We're going to be looking at getting into chapter 3, and the plan, just so you know, is to get through chapter 3 and test before we go into break. So we're going to spend quite a bit less time on this than chapter 2. So just know that going in. So that probably means that you should do a little bit better job of keeping up on the assignments as they come. There probably won't be a mid-chapter quiz. So anyways, we'll just kind of go straight through and we will test at the end. So, you know, last chapter, chapter 2, was all about solving equations and proportions. This one is all about solving inequalities. So the first lesson is kind of an introductory lesson. It's called Inequalities and Their Graphs. Not a whole lot of actual what you might call, you know, math or computational math, but just kind of understanding the basics is the thing. So your learning targets are, after this lesson, we will be able to write, graph, and identify solutions of inequalities, and also to express solutions of inequalities using interval notation. So interval notation will be new, but it's a nice thing to know once you know it. On that note, let's jump into some examples. So example 1 is about learning how to write inequalities. If I give you a word phrase, you turn it into an inequality. This is a very good skill to have because there are all kinds of word problems in math. So 1A says all real numbers x. So x stands for all real numbers less than. Sorry, it says less than or equal to, right? So less than or equal to is going to be that one right there. And then less than or equal to what? The number 7. So altogether, it looks like this. X is less than or equal to 7. Okay, that's all we're asking for on this one. I'll do maybe, let's do one more. Let's skip over to D maybe. So D says 6 more than a number K. That'd be K plus 6 or 6 plus K is less than or equal to, so same inequality symbol, probably should have picked a different example, the number 12. So altogether, K plus 6 is less than or equal to 12. All right, I'm going to pause the video at this point and ask you to try example 1B. And then you can check that on the filled out notes as well. Same for C. All right, looking at example 2, identifying solutions by evaluating. Now, you might look at this and say, so it says, are the following solutions to 2x plus 1 is greater than -3. So you might look at that and try to solve for x, which wouldn't necessarily be wrong, but well, I'll just kind of show you, you know, what we're doing here. So all I'm asking you to do is sub in, you know, this value. So this means is x equals 3 a solution to this, right? So this is kind of checking your answers. So I'm going to sub in -3 right there and just see if it's true or false. So we're saying 2 times -3 plus 1. We want to know, is that greater than -3? So what we need to do is evaluate well, you could say evaluate, simplify the left side. So that's -6 plus 1 is -5. So that says -5 is greater than -3. Be careful with the negatives. You might tend to think, well, yeah, 5 is bigger than 3, so yes. But negatives are kind of counterintuitive, right? -5 is to the left of -3 on the number line. So this is false. So this would be a no. -3 is not a solution. All right. The other way to approach this problem, so that would be one approach. The other way would be if I'm comfortable enough to solve for x, then I could go like this. And this is getting a little bit ahead, so you don't have to do it this way. But some of you I know are going to want to, so I'll show it this way. So if I solve for x, I'm going to minus 1 from both sides. That would be 2x is greater than negative 4. Divide by 2, we get x is greater than negative 2. So then we can easily compare now. So we could easily see that negative 3 is not greater than negative 2, so that'd be a quick no. Negative 1 is greater than negative 2, so this one would be a yes. All right, so I'm going to ask that you go ahead and figure out example A. All right, and again, if you're having trouble, just so you get it right on the Ed puzzle, you can reference your filled out notes to make sure that you get that answer correctly. And then you can also see B and C worked out. Okay, moving on to, let me make sure I'm on the right example. Yeah, this should be example 3 down here. So example 3, graphing an inequality and introducing interval notation. I don't know if interval notation is actually on, well, you're not going to have a Math Excel, so never mind, scratch that. All right, so I'm going to represent these answers in 2 different ways. Okay, so first of all, why would I have to graph an inequality? Why can't I just leave it as A is less than or equal to 2? Well, how many numbers are there on the number line that are less than or equal to 2? The answer is infinitely many, right? So the only way we can show infinitely many solutions is on a number line. Okay, so that's why we graph these the way they do. So a traditional graph would just be, you know, the part of the number line you care about. So we want 2 to be part of it. I usually like you guys to show 1, 2, and 3. So just the small part of the number line. Okay, if it's or equal to, we show that, well, this says that 2 is included, so we show that on our graph with a closed dot, either on 2 or I like to do it above 2. But it's a closed dot, anything that's or equal to. If that said greater than or equal to, it still would have been a closed dot. The less than part, we're going to shade either to the right side or to the left side. So you have to think here, where are the numbers that are less than 2? Right? So 1 is obviously less than 2, and anything to the left is going to be less than 2. Left is less. So you want to shade to the left. So that'd be closed dot, shade to the left. Closed dot, shade to the left. Anytime you have less than or equal to. So that's one way. You guys are probably familiar with that. Interval notation is going to be new. You don't have to pick up on this totally, but I'm going to go ahead and introduce it. Right? So interval notation is basically, it looks almost like an ordered pair. So you have your lower boundary all the way up to your upper boundary, right? So if I keep going forever to the left, where am I going to go? I'm going to head towards negative infinity, right? So we go negative infinity is my lower boundary, comma, what's my upper boundary? Well, I can go all the way to positive 2. So positive 2 is as big as it gets, okay? Now, for interval notation, you can either close either side with a parenthesis or a bracket, okay? So you use parentheses if your boundary is not included. Since infinity or negative infinity aren't real numbers, those are automatically always in parentheses, okay? Infinity is more of an idea than an actual number. I know that's kind of confusing, but just know that your infinities are always in a parentheses, all right? And then 2 is actually included because it says or equal to. So this needs to be in a bracket. So both of these things mean the same thing. All right, let's do another one. So ones like B and D can be a little bit confusing because, well, format-wise, what's different? On these 2, your variable's on the left side. We tend to read left to right, so, you know, like I said, that can be confusing if they are flipped around. I don't care if you leave it this way, but I suggest you rewrite it variable first. So you got to imagine here that this is like on a hinge, right? So if we flip everything around, including the inequality symbol, this is the same thing as x is greater than -4. So one reason that is a little bit confusing is people think that, oh, I thought we just flip the inequality symbol if we multiply or divide by a negative, kind of previewing something ahead that's coming in the chapter. Well, we didn't flip the inequality symbol, we just rewrote this in a different way. So -4 is less than x is a synonym to x is greater than -4. X is greater than -4 is just a little bit easier way to think about it for me. Also, another thing is when you graph this in a different color. When you graph it, you might have been taught the arrowhead trick. You can't use the arrowhead trick if the variable's on the right side, okay? Anyways, I want to see -5, -4, and -3 on my number line. It is not or equal to. So if it's not or equal to, we don't close in the dot. We leave it as an open circle, all right? And then where are the numbers that are greater than? Well, if left means less, then right must mean greater than. All right, so again, when the variable's on this side, you can just use that arrowhead trick, right? The arrowhead points to the right, so that's we know to shade to the right, okay? I don't tend to like to think about the arrowhead trick. I like for you guys to think about what we're actually doing, right? Where are the numbers that are greater than -4? They're to the right. But if you like to use that arrowhead trick, you have to have variable on the left side. All right, interval notation would be, what's my left bound? What's my smallest number that we go to? That would be -4. And then as I keep going to the right, I'm going to keep getting closer and closer to infinity, so it goes up to positive infinity. And the infinity symbol is like a sideways 8, okay? So now we decide which one is included. Well, we know infinities aren't ever included, so you can put an automatic parenthesis there. Now, is -4 included? The answer is no. I can tell because it's open and also because my inequality symbol does not have the or equal to part. So we put that in parentheses there too. Okay, so again, this means the same thing as that. All right, I'm going to go ahead and stop it at this point and ask you to fill in D. And again, you might want to really check your notes because if you miss this, this will be like a point off on your homework. So you might want to double check on your notes before you answer the question. All right, so a couple more types of examples and then we'll call it a day. And these diagrams are a little bit difficult to see, so I apologize about that. If we're given a graph, can we write an inequality that goes with the graph? All right, so here are the kinds of things you should be looking for. First of all, your boundary is -2, right? So you know -2 is going to be involved. That's an easy part, okay? It's hard to see here, but I will tell you that this is a closed dot, okay? So I know that also or equal to is going to be part of this. It is also shaded to the right, okay? So what's to the right? That's greater than or equal to. So greater than goes this way. All right, so greater than or equal to -2, and the only thing that goes on the other side is a variable. Okay, it can be X every time. I'll just use A because we're on example A. So that's kind of the thought process of how you do these. All right, I'll skip ahead to, well, I'll let you do example C. All right, and again, you can find that on the notes. Last problem, some real world problems written as inequalities. Okay, so these are good skills. I might go through, well, I'll go through at least 2, maybe leave you the third. So 5A says a person must be at least 35 years old to be elected president of the United States. Kind of a timely example right there as we have the election right around the corner. So first thing we want to do is kind of define our variable. So we're talking about people's age. persons, let's see. It doesn't say the word age here, but it's assumed we're talking about age. So let's let A equal age of person. The big thing on this is the inequality symbol, right? At least is a very common kind of nomenclature you're going to see on an inequality problem. At least, what's that mean? So that means you have to be, you could be 35, you could be 36, you could be 85, you could not be 34. So anything that is 35 or over, right? So as an inequality symbol, that would be greater than or equal to, okay? So we'll have A is greater than or equal to 35. That's how you can write that as an inequality. All right, and then the last one, the B, the gym can seat at most 3,000 people. So in this case, we would let gym or G be the gyms. That's not how you spell gym. Sorry about that. G is going to be the gym's seating capacity. Okay, so on this one we have at most. Sounds similar to at least, but it means something different, right? So this would mean, you know, if I'm not sure what the inequality symbol is, think about it, right? So could I have 3,000? Sounds like, yeah, we could have up to 3,000. Could I have 3,500? No, not if we can have at most 33,000 people. Could I have 2,500? Yes, right? So on this one, this would be less than or equal to. All right, so we would just finish it out. G is less than or equal to whatever our boundary is, in this case, 3,000. All right, and then I'm going to have you guys finish this ed puzzle by filling in the answer for C. If you notice, your homework assignment is actually the ed puzzle, so you will not have a Math XL for this lesson, which would be nice for a lot of you guys. So hopefully you're just done with this by the time you leave class today and you're all caught up, and maybe you can work on that project for homework if you have lots of work to do on that. Remember that that project is due Thursday. All right, guys, so that's all I got. Thanks for your time. Hope this helps. And remember, we're going pretty quick through chapter 3, so stay on it. Don't fall behind. Y'all have a nice day. Thanks.